The USGS letters and slogan "Science for a Changing World" appear in white in a flipping motion, then fade to black.
Hello, everyone. Welcome to the USGS Hydrography Community Call. I'm Karen Adkins with the National Geospatial Program User Engagement Office. This call is being recorded and it will be made publicly available on the USGS website, on YouTube a few days after the call, and links will be sent out to subscribers of our Gov Delivery topic, the 3D Hydrography Program. So we'll go ahead and get started. Today, Steve Aichele, the Management and Planning Lead for Hydrography, is going to make a few announcements. So Steve, I will turn it over to you.
Okay, thank you. So this is our sort of a quarterly update or quarterly check-in here. I have a number of things that we got done last quarter. First thing, the final WBD watershed boundary data set has now been published. That's available in all the forms you're accustomed to as a national downloadable product, as a downloadable product by 2-digit hydrologic unit, and as a map service. We're also working on getting that transferred over to the new feature server, which I'll mention in a minute. But that data is now static. That's sort of legacy data. It's locked in. That's depending on who you are. That's kind of a pro or a con, but that's where that is. And going forward, we'll work on creating drainage areas that are similar to the hydrologic units out of 3DHP and by aggregating catchments. But that's that WBD data is now finished and locked in. We've also published 3DHP downloadable data sets for last year. These are the first of the annual staged products that we'll be creating, and those are available off of our new data access page that I guess I'll show you that in a minute. But they're 2 files, one for Alaska, one for CONUS, and in 2 formats, one in geodatabase and one geopackage. Those are basically the state of the data set at the end of September, at the end of FY24. And that we'll do that again next year and show you what we published during FY25. This next one is actually fairly exciting, or at least, fairly exciting to me. Then we actually have a new feature service up as well. And so if you go to this, this new, what they call endpoint URL, you'll see there are actually both, there's a map service and a feature service there. The map service is the same as the map service we've had. The new feature service, though, is both faster and gives a lot of the flexibility you would expect to see in a normal downloadable data set. So if you need to, if you want to select all the rivers named Susquehanna, you can do that, at a relatively brisk pace, even out of 30 million or so features. Also gives you a lot of cartographic flexibility if you didn't like the cartography that we had on the map service. And then finally, with new elevation-derived hydrography specifications, these are updated and released on the internal or on the public website. But for data producers, if you're a contractor or cooperator out there making the data, make sure you work with your project manager to use the appropriate version for your agreement or task order. Okay, and with that, I'm going to grab the screen here for just a second, Karen, and show our new data access page. There we go. And so if you go to usgs.gov/3dhp, or you can also get there 3dhp.usgs.gov. Roll down. This is very similar, but over here, we've accessed 3DHP data products. And this page is a little bare bones at the moment, but the content's here. So we have the new feature service. which actually just looks like, web page here. We also have the map service, and then the downloadable data products. This goes to a science-based page with a fixed DOI, so it's referenceable, and then each of the data sets are listed down here. This is just a little bit tidier than the way we were doing it, linking directly to the Amazon Web Service before. And as additional data sets, there's the DOI. As additional data sets come in, or as we generate additional data sets, we will, add new pages. So those are all, continue to be referenceable. And then down below that, we've transferred over the legacy product links as well. And so, for example, again, this is the kind of thing we were getting with the previous link directly to Amazon Web Services. Eventually you get there, but that's not how we're doing it anymore. So, feel free to poke at that at your leisure. If you feel, we'll continue to add new products and services to that as we roll them out. But, kind of excited about that.
All right, so today we have a special topic. Mike Tinker is a cartographer with the USGS National Geospatial Technical Operations Center, and he is going to provide a presentation called HydroAdd3D Sneak Peak, next generation web-based addressing tool for 3D-HP.
Thanks very much. So today we're going to talk about HydroAdd3D, our next generation web addressing tool for 3D-HP. As many of you know, the current instance of HydroAdd for NHD allows you in a web interface to address your data to the NHD. That is to say, to make the features in your data coincident to the NHD while also conflating or spatially joining some of the attributes of the NHD features to your data features. Users can collaborate on projects by working on a common data layer. HydroAdd uses ArcGIS Online to host the user's data. Addressing your data to a hydrographic network such as NHD or the new 3D-HP, which we're building now, allows you to track your own geospatial assets in relation to the hydro network. It also allows for geospatial analyses. So in this presentation, I'm going to show you some real-world use cases of address data. I'll touch on some of the issues we encountered addressing big data with the first generation HydroAdd, which will illustrate the reasons that we're building the next generation of HydroAdd, HydroAdd3D. But for the newbies, I'm going to explain in just one slide what addressing means. Some of you have seen some of my slides before, but bear with me, I have plenty of new slides today. So this is an addressed stream gauge in the NHD that has a network address. It's a bit like a street address. The routes are the stream flow lines, the reaches. Every reach has a unique reach code, and every reach, no matter how short or how long, no matter how sinuous, has meters from 0 to 100. Think of meters as a percentage upstream, with 100 being all the way upstream at the headwater or the top of a confluence. So the address is the reach code plus the measure. The address plus all the codes comprise the network addressing system. So this USGS stream gauge sits at this reach code ending in 0421. One of the main benefits of a network address is that it allows you to resynchronize your address data when hydro data is updated. The world changes, rivers move around, data sets change, but as long as the routes don't change names, you can resync your data. There are other terms you will hear for the act of addressing, such as linear referencing, indexing, linking. These all mean the same thing. The other terms below, such as hydrolocation, address data, reference data, those describe the actual data itself. I still use the word event quite often. It's kind of an old term and got some baggage, but it's still very widely used in hydrography circles. Right off the bat, I'd like to say you can address anything to a hydrographic network, such as NHD or 3D-HP. So the question is, what is your business need? So let's talk some real world use cases. Some of these use cases will illustrate why we're building HydroAdd3D. I often show this slide because it's a classic example of how Addressed data allows modeling and analyses. In this map, the width of the flow lines shows modeled stream flow in cubic feet per second. This model is possible because we addressed USGS stream gauges. NHD plus V1, V2, and NHD plus high res all use a similar logic to model stream flow and velocity, but this model would not have been possible at all without thousands of carefully addressed stream gauges. This slide is also a good segue to talk about how linear density affects hydro addressing. NHD plus high res has more than 30 million records. We expect 3D HP data that we're building now to have an order of magnitude number of features. We're also expecting some very dense address data and need HydroAdd3D to be able to scale to keep pace with that. This is a snip of designated US wild and scenic rivers in Alaska. We put the designated wild and scenic rivers on our US topo product. So as you can see, address data doesn't have to be points, it can be lines too. An addressed line has a start point and an end point, and the intervening geometry is exactly coincident with underlying flowline features. Wild and scenic rivers was the first big data project where HydroAdd was used. Tara McKinnon at the US Forest Service used HydroAdd to address both the designated and eligible wild and scenic rivers to the NHD. The initial wild and scenic river designated data had about 25,000 line features, but some very long line features would get snagged during editing because of the way that HydroAdd communicates with ArcGIS Online, where we host the user data. So the line features had to be diced into smaller pieces, which more than double the number of features. She had to do a lot of manual editing. In many cases, we had trouble with traces following weird braided features rather than the main stem. Also, lines batch QC queues had to be parsed into smaller queues of about 1,000 features each, so that batch QC wouldn't freeze up. But we learned a lot with this project, and we made some improvements to HydroAdd. And some of those improvements we will implement in HydroAdd3D. Here's another more recent use case for modeling. The Northeast Stream Temperature Database. Matthew Fuller at the Forest Service is using batch QC to do the addressing work. This data set has about 8,300 points. Now, batch QC can handle point data of this size. However, publishing 8,300 points back to ArcGIS Online would take close to 2 hours. The current HydroAdd3D beta can publish 8,300 points in about 20 seconds. I'll talk more about that in a few more slides. Here's another use case. Shuyang Zhang at the California Department of Pesticide Regulation maintains a surface water database called SURF. It's not very exciting to look at, but it has nearly 1,050,000 records of chemical pollutants in surface water streams. It's time series data, so there are very many coincident points stacked up. Batch addressing this much data with HydroAdd would take a really long time. Publishing to ArcGIS Online alone would take like 10 days, best case. But with HydroAdd3D beta, we could publish 1 million dots in about 45 minutes, and maybe faster than that. I haven't tested it with 1 million dots yet, but I will. I think we can get there. Okay, so I'm using this slide to illustrate my last two use cases, and those are fish distribution databases. These tend to be very large and complex data sets. In the first case, John Bowers of Oregon Department of Fish and Wildlife manages the Oregon fish habitat distribution data. It currently has 91 fish species and nearly 103,000 records. In the second case, Edmund Hall, Forest Service in Region 6, maintains a fish species distribution database with about 141,000 records in Region 6. So these are big line event data sets. It's complex data. Many fish species are overlapping on single flow lines, and many of the fish species line events are not continuous lines. They break or scattered about. So even manual editing gets messy. But honestly, data like this is too big for manual editing because it would take too long. And the current version of HydroAdd Batch QC just can't handle data this big. Both QC and publishing of results would take too long. So that brings me to the next iteration of the tool, HydroAdd3D. So those real world examples led us here. What are the big picture goals for the next iteration of HydroAdd? Well, you want the ability to batch process very large data sets and publish them quickly. We want the ability to migrate to 3D HP from previously addressed NHD that is to crosswalk from reach codes to 3DHP main stems, and it needs to be free to users. Now, I love ArcGIS Online as a hosting platform. I do, but it's not free, and it's too slow for HydroAdd. So how do we get there? The big picture solutions to our goals are we parallelize batch QC processing, we parallelize publishing, and we replace ArcGIS Online with an open source hosting platform called GeoServer backend with GeoNode on top as the content management system. And finally, in the near term future, we want to move the application to the cloud. This would also improve performance and give us instant scalability. Here's the very first snapshot of HydroAdd3D interface. It looks pretty much like HydroAdd for NHD, but by the time we release the main UI, we'll have a few tweaks. But let's talk about the differences related to addressing to 3DHP versus addressing to the NHD. First of all, HydroAdd will address to main stems, not reach codes. The route identifier and 3DHP are main stems. Second, we're calling the address data that we will include in 3DHP hydrolocations rather than events. And third, HydroAdd will conflate X, Y, and Z coordinates, but not measures. 3DHP flow lines will not have measures. I'll talk about most of the other things in this table in the following slides. First, main stems in 3DHP. In early releases of 3DHP, most main stems will be the same length as reach codes in NHD because the initial releases are just the NHD ported to the 3DHP schema. But as EDH deliveries get processed and 3DHP work units flow out of production, the Hydro will start to look very different. The main stem attribute lives in the flow line feature class. The main stem ID is just the integer at the end of the URL. Now, maps in HydroAdd3D won't show this entire URL as the label, but it will just show the integer. But I'm showing the entire URL here to illustrate the point that main stems are designed to resolve to a page on the Internet of Water. And here is a page in GeoConnects, the Internet of Water site for the Platte River main stem. As you can see, there's various attributes. Platte River the right side pane and the left side pane is a little map of the main stem. So main stems can be very long. They can represent an entire river from headwater to outlet. I always show this slide too because I get such a kick out of it. This is the 3DHP Platte River main stem, but the circles on top show the NHD reach code breaks. And while the Platte River main stem is just one feature, in the NHD, the Platte River is comprised of 1,876 reach codes. So reach codes can be quite short compared to a single main stem. One of the feature classes that we will include in 3DHP is the hydrolocation feature class, and one of the hydrolocation feature types are the starting and ending points of every NHD reach code. So the Platte River section of the hydrolocation table is shown here. You can see hydrolocation points in the map above, but in the table, you can see the reach code start points and the reach code endpoints ending in 4011. So the hydrolocation feature class is essentially an NHD reach code archive, but it's more than that because this is the crosswalk table that HydroAdd3D batch QC will use for migrations. So if you have previously addressed data to the NHD and you have reach codes already, batch QC will use this table to migrate your events to 3DHP main stems from reach codes. What this table really shows in my mind is how we're simplifying addressing to an XY pair on a single main stem, as opposed to many thousands of reach codes and measures. By the way, batch QC for HydroAdd will honor the main stem, reach code, GNS name, GNS ID in that order. So if you have any of those in your existing data, you'll get much better results on your QC. While HydroAdd for NHD, batch QC honors only reach code and genus name in that order. So as you probably gathered, HydroAdd3D will have Z values on vertices, with a caveat. Most of the current 3DHP is just the NHD ported to 3DHP schema. So NHD derived 3DHP will not have Z values until those areas are erased and replaced. But as EDH deliveries get processed, 3DHP Hydro will have Z values on the vertices. In those NHD derived areas, without z-values on the vertices, HydroAdd3D will use a 3DHP elevation point query service to collect the z-values. One of the frustrations users have with HydroAdd is addressing to the primary path in highly braided areas. This is the South Platte River heading east out of Denver, where I live. This area is my favorite punching bag in the NHD because it's a classic example of messy braiding. Like, where's the real South Platte River main stem and all these braids? When users make line events with HydroAdd, it makes the shortest path between the start and the endpoints. And in braided areas, this often means the traces follow all sorts of unpredictable flow lines. So one of the ways to solve this problem is by isolating the dendritic network. NHD Plus has value-added attributes that allow the identification of the dendritic lines. NHD Plus also has a level path identifier, which is essentially the primary path. So 3DHP will eventually have a level path identifier in EDH-derived areas. But again, NHD-derived 3DHP won't have a level path. So for HydroAdd3D, we'll probably use dendritic streams as a proxy for level path because we already have the dendritic network nationwide. As you can see, it's a pretty good proxy. The dendritic network cleans up all those braids. And here's what that would look like in practice. This is a mock-up HydroAdd3D trace UI. We haven't built the real UI yet. There's a little box the user can check to address only to the primary path. So the editing crosshairs would light up only over the primary path, and Batch QC would have this function too. Speaking of trace, HydroAdd3D, speaking of trace, 3DHP will not have an Esri geometric network, but like the NHD, it will have a network flow table. There are algorithms that can find the shortest path between any 2 points on a network table. So we can use a little graph theory to operate on the flow table to find the shortest path between 2 points, and we can narrow the candidates by using the primary path. The other thing I want to point out in this trace UI is the stop at main stems level checkbox. So from a point or from starting points, you could trace upstream, say 2 main stem levels, and light up the main stem and all its tributaries, or stop at 3 main stems and you would light up the tributaries of the tributaries. Give it a high enough number and you could light up the entire upstream network. Likewise, you could trace downstream, 2 main stems or 3 main stems. Give it a high enough number and you could trace downstream all the way to the ocean. But also notice the save button here. We want users to be able to save their traces as line events back at their service. Here's a mock-up of the Make New Point UI. It looks pretty much like the Make New Point in the current HydroAdd, except that it has that snap to primary path only checkbox. Likewise, this is the mock-up of the Make New Line UI. It will also have that snap to primary path only checkbox. Okay, so we are indeed moving our hosting platform from ArcGIS Online to GeoServer, and an open source hosting platform. And while GeoServer acts like the backend hosting service, the integrated front-end content management system is called GeoNode. This is what the beta implementation looks like. I'll demo this in just a moment. Initially, the GeoServer GeoNode instance will be deployed on premises, that is sitting on NGTalk hardware. But eventually, we want to deploy the entire HydroAdd3D application and the CMS to the cloud. In the current implementation with ArcGIS Pro, users have the option to share data to ArcGIS Online, where you get instant web feature services, which is pretty cool. But as I have explained, ArcGIS Online just isn't quite fast enough for the kind of data that our users have. So the new workflow would be to upload your data to GeoServer using the GeoNode CMS. Just having your data right next to the processing, we think we can achieve much faster performance in batch QC and publishing. And when we take the application to the cloud, we expect greater scalability and further improvements in performance. In this screenshot, you can see I've already added several different data sets to the GeoNode content management system. So here's an upload. To upload, go to Add Resources and upload your data set, drag in your geo package, hit upload, wait for the upload to finish, and there it is in GeoNode. Note that we're using a geo package here. I'll talk more about that in just a sec. Going full screen now for GeoNode, you can view all your data sets, choose a data set, thumbnail, click view on the thumbnail, go over to the top right pane there, copy the URL. Now go back to HydroAdd3D in my profile, click add the service as usual, paste in the URL, give it a title, hit submit, and the data instantly appears. This should look familiar to you because it's the same workflow as the current iteration of HydroAdd. Also, GeoNode does allow you to share data with people and groups, so you can collaborate on projects with HydroAdd3D, the same as you do now with HydroAdd. A couple words about geo packages here. First, HydroAdd3D requires use of geo package rather than geodatabases. GeoServer, being an open source platform, will not host an Esri proprietary geodatabase. And I know that most of our customers are probably working in Esri shops. You've all probably got pretty tightly integrated ArcGIS Pro workflows. We appreciate that working with geopackages is going to be a change, but geopackages are fairly common these days. Most people have worked with geopackages. They're kind of like the new shapefile. You can make geopackages easily with ArcGIS Pro. You can also use QGIS to make geopackages. That's coming. On our side, we will need to do a bit of research on our part to ensure that object ID is used as primary key. QGIS integrates with GeoServer in a similar way that ArcGIS Pro integrates with ArcGIS Online. Hopefully I can show you that next time we meet. Note that geopackages do not support domains. HydroAdd schema uses coded yes/no domains for the QC field. So with HydroAdd3D, with the HydroAdd3D schema, we'll drop the domains for the QC fields and go with straight text. By the way, HydroAdd3D schemas are updating, still fairly close to the current schema. In this table, the highlighted updates are in yellow. It doesn't look like big changes, but a group of us addressing nerds at USGS collaborated over many 1-hour bi-weekly meetings to dial all this schema in. The updates are analogous over here on the line schema. User authentication will change from ArcGIS Online to GeoNode, and we may eventually add login.gov. So the same way that ArcGIS Online login is integrated with HydroAdd now, GeoNode authentication will be integrated with HydroAdd3D. With login.gov, we're still researching and trying to get a little bit of guidance on that. So we're getting close to the end of the presentation, but I would be remiss if I did not mention this. We're already seeing huge improvements using GeoServer on-premises implementation. So 2 weeks ago, we did a publishing test with 50,000 points. That took just 2 minutes, which is amazing because 50,000 points used to take about 11.5 hours, best case. So Matthew Fuller's stream temperature points would take like 19 seconds to publish rather than 2 hours. Xuyang Zhang's 1 million points of California pesticide samples would take about 45 minutes rather than 10 days. If you do the math, publishing to GeoServer is like 347 times faster than publishing to ArcGIS Online. And I think we can do better still when we get to a cloud deployment. So this is where we're at with our current development tasks. We're working on GeoServer, GeoNode. We're working on point addressing for 3DHP to a primary path. We'll do point batch QC and 3DHP. This year, we're going to be building a query builder for selections rather than just having a source ID. Search by main stem, genus ID, genus name, reach code, hydrolocation. Those are the things we're working on right now. In the intermediate term, we're looking at line addressing and line batch QC. Longer term, we're talking about polygons and polygon batch QC.
Thank you so much, Mike. You are welcome to send questions to Mike. And you can also use the 3DHP general email as well. So hopefully you'll get lots of questions coming soon. Looking
Or
forward
email
to
to, sorry, Karen, email to HydroAdd@usgs.gov. I should have put that on here, HydroAdd@usgs.gov.
feel
All
free
right, thanks for the
to.
invite today. It's been a pleasure.
Thank you very much, Mike. Really appreciate the great presentation. And we're all looking forward to seeing HydroAdd live. But I did want to let everyone know that our next hydrography community call is planned for April 22nd, 2025. We should have more announcements then. Lots of things happening with 3DHP this year. And any updates on changes or to product services, the website, anything like that. And then we don't have a special topic yet, but we may have a special topic for you, and we'll send that out to the Gov Delivery subscription list. All right. Well, thank you, everyone. Please join us April 22nd, and I hope you all have a wonderful day. And thank you, Steve, and thank you, Mike, for excellent presentation and demos. Great work today. Thank you, everyone.
The USGS letters and slogan signs for a changing world appear in white in a flipping motion, then fade to black.